Hello again, this is Gary Millett. I'll be your guide for this particular course. This is wireless network technologies, and our first topic is talking about wireless system standards and standards organizations. So, since it's predicted that most future IoT applications will be implemented through the use of wireless technologies, it would be instructive to look at the various industry, government, and standards organizations that are involved in the decision-making process concerning this dynamic technology field. Then, emphasis will turn to the organizations involved with decision-making for the various different industries that are involved with the use of IoT technology. We'll highlight medical devices industry and automotive industry use of wireless data transmission. So, this is a slide from IoT Analytics, and the question is, how will IoT devices be connected? It's a fairly recent slide. You can see Q2 of 2020, and this predicts how future IoT devices will be connected to the internet. If you take a look at this, it runs from 2015 all the way to 2025. The A after 2015 actual, and after 2020 it says F for forecast. So the data is actual up to 2019 and forecast all the way to 2025. If you take a look at the colors there, you see mostly red or some type of hue of red. The bright red is wireless personal area networks or wireless PANs. That's a big bulk of things, as you can see. The next, not as bright red, is wireless local area networks or wireless LANs. The next shade above that is cellular, 2G, 3G, and 4G. And the lightest shade, the pinkish kind of color, is LPWA, which stands for low power wide area networks. The blue is wired or Ethernet, hardwired. Other is gray. 5G is a darker gray, and a lighter gray is wireless metropolitan area networks or wireless MANs. So if you take a look at that, you notice there's a relatively low number of IoT devices predicted to be connected to the internet via hardwired, and we say Ethernet LANs connections. That's the dark blue color. So let's move on to the next slide. Usually in wireless we have spectrum policy and regulatory issues. So as wireless technology has matured, there has been a growing need for entities that deal with issues related to spectrum policy and regulation of the radio spectrum. In the United States, the early radio broadcasting era was somewhat like the Wild West. If you wanted to start a radio station, you could. There was a Radio Station Act, or Radio Act of 1912, that stated that every radio station needed to be licensed and operate on a frequency between a certain wavelength range. Otherwise, there were very few other restrictions. Other early U.S. regulation was later in 1927. We had the Radio Act of 1927. It was passed in an attempt to bring order to what had been the chaotic development of radio broadcasting during its early years. Now, radio licenses would specify the power level and frequency in an attempt to bring some order to the rapid development of the industry. There was a thing called the Federal Radio Commission, the FRC. It came into being. It was after 1927. Well, it turned out as we get into the early 1930s, the Federal Communications Commission would replace this organization in 1934. So what is the FCC? Well, ever since its inception in 1934, the FCC has served as a regulatory arm of the government, dealing with and regulating new wireless technologies as the field has evolved. Certainly, in the U.S., this has included the assignment of various frequency bands to different services. Now, this has been an ongoing process as new wireless services have been introduced. For instance, television, we had VHF and UHF, FM radio, cellular, IEEE wireless technologies, and so forth. I'm going to change gears a little bit, talk about the UNII bands. So originally known as the ISM, which stood for Instrumentation, Scientific, and Medical bands, Internationally defined by the ITU, these bands were reserved for non-telecommunications uses and did not require licensing. Now, they are more commonly known as UNII, which stands for Unlicensed National Information Infrastructure Bands. These bands have been used for low-power data transmission systems like IEEE 802.11, which is Wi-Fi. Today, there are many UNII bands in use around the world for different types of wireless applications. So this slide shows the UNII bands, and you notice they go all the way from 6.765 megahertz all the way up to 246 gigahertz. Now, some of these you probably never heard of, and you notice that, for instance, region 2, the blue there, 902 to 928 megahertz. That's a band we do use in this country. Notice 2.4 to 2.5 gigahertz. It's a Wi-Fi band. 5.725 to 5.875 gigahertz. Again, another Wi-Fi band. Then there are bands way above in the millimeter wave frequency where we don't even have components that allow us to build things for those particular bands. But it won't be long before we do. So it turns out a lot of UNII bands available. As you notice, some of them are, say, subject to local acceptance, whereas others are worldwide. So what about regulation around the world? Ever since the advent of radio broadcasting, different countries around the world have taken different steps to regulate its use. However, we know radio waves do not recognize boundaries. Hence, international or regional organizations have been more involved in spectrum policy and regulation. The European Union has recently formed the Radio Spectrum Policy Program, or RSPP, and the Pacific Rim countries have their regional organization, Asia Pacific Telecommunity. What about the ITU? Well, the ITU, which is the International Telecommunications Union, is an agency authorized by the United Nations to deal with regulatory issues on a global basis. An international treaty developed to deal with radio. The ITU has 3 subdivisions that deal with radio communications, standardization, and development. The radio communications section deals with the spectrum needs of new and emerging wireless applications. There's a link that you might want to take a look at to the ITU. What about the WRC? Well, again, one of the ITU's most important activities is spectrum policy, and as such, it sets the agenda for the International World Radio Communications Conference, or WRC, that meets every 3 to 4 years or more often if needed. Prior to modern times, it used to meet less frequently when it was the WARC. At the WRC conference, each member has a single vote or equal say in what happens. Now, since many nations are not involved in the wireless industry, they tend to vote for what the ITU proposes, and that's usually determined beforehand. So we recently had a WRC 19 back in 2019. Some of the topics of interest that were discussed at this WRC meeting were possible new 5G cellular frequency bands in the millimeter wave region. And another topic of interest is the radio bands between 5150 megahertz and 5925 megahertz. Some of these 5 gigahertz frequency bands are already used for unlicensed Wi-Fi services, but there is a worldwide desire to increase the spectrum in this range for higher bandwidth and data throughput for Wi-Fi systems. So here's an update from the WRC 19 meeting. That was held again the 28th of October through the 22nd of November in 2019. So the addition of new bands for 5G, which is known as IMT-2020 by the ITU, 24.5 to 27.5 gigahertz, 37 to 43.5 gigahertz, 45.5 to 47 gigahertz, 47.2 to 48.2, and 66 to 71 gigahertz were identified. And that's quite a bit of bandwidth. The frequencies in the 40 to 50 gigahertz range are not worldwide. Use of 4.8 to 4.99 gigahertz is okay in 40 countries at this time. The 20 to 30 gigahertz range has controversy due to weather satellites at 23.6 to 24 gigahertz. There's fear by the weather forecasting community that we will interfere with those weather satellites. More frequencies for Wi-Fi in the 5 to 6 gigahertz range, And at this point in time, it looks like the agenda for WRC 23 will deal with frequencies above 71 gigahertz. Now, mind you that we don't really have much equipment for those very, very high frequency ranges. So how do we implement WRC radio regulations? Well, in theory, decisions made at the WRC are binding on all nations, but quite often some of the participating nations are exempted from these new regulations by the grandfathering of already existing radio services. An example of this is in the rest of the world, the 3.5 gigahertz frequency band may be used for unlicensed Wi-Fi. However, in the U.S., this band was reserved for military use, the early warning missile defense system on the east and west coast. So recently, this is a little bit over a year now, on January 27th of 2020, the FCC authorized full commercial deployment in the 3.5 gigahertz band. And there's a link to that regulatory authorization. So let's talk about wireless system standards. We want to consider the standards that govern the wireless equipment used by the various wireless services. And for decades now, in order to allow for interoperability between equipment from different manufacturers, equipment built for the same purpose, standards have been put in place that guarantees that this will be so. In a global economy, this is the only way that the guarantee of interoperability may be kept. So let's take a look at non-data networking wireless standards. Let's consider the non-data networking wireless technology systems used by automobiles as sensors for advanced driver assistance systems, or ADAS systems. Radar technology is considered to be a key technology for implementing automotive ADAS systems like collision avoidance, which at this point we call AEB, or automatic emergency braking systems. Although these automotive radar systems are low power, it's typical to have a government agency that regulates the transmission of RF radiation within a country, and that in the U.S., this entity is the FCC. In the U.S., the only regulation of the low-power radar systems used with automotive ADAS systems is done by the FCC. These regulations are only related to the frequency of operation and other technical characteristics of the RF signal emission. In February of 2015, the FCC issued a Notice of Proposed Rulemaking, it's called an NPR, that modified various previous rules to allow for the operation of vehicle radars in the 76 to 81 gigahertz band, and this operation would be unlicensed. So prior to this, there were other vehicle radar systems that worked in different frequency bands, notably between 22 and 29 gigahertz. But it now appears that the manufacturers of these devices have settled on this higher millimeter wave band as a default standard due to improved operating conditions and characteristics. Notice that there are no present standards related to the vehicle radars themselves. Manufacturers are free to design and implement whatever systems that they believe will do the job. This brings us to LiDAR. LiDAR is considered a wireless system even though it uses light frequencies or wavelengths in its operation. Actually, IR wavelengths so as to be safe for human eyesight. There are no FCC regulations for these types of systems. The only restriction involves output power levels and eye safety. You want to see the ANSI standards for visible light. Typically the human eye, and it's unknown for other animals, does not focus wavelengths other than visible light. However, very high powers can cause burns of your eye or your retina. So early on in the development of wireless data networks, there were proposed European standards, and that's the ETSI, for a type of wireless data networking system called HyperLAN, and also some competing Japanese standards. As has happened many times before, the marketplace tends to dictate on what becomes known as the default standard. In this case, the standards proposed by the IEEE won out. The first Wi-Fi standard was known as IEEE 802.11, and since then the IEEE has been in charge of maintaining the 802.11 standard. Today there's a suite of IEEE wireless technology standards for data transmission. The most well-known IEEE standards are, again, IEEE 802.11, which is Wi-Fi, IEEE 802.15, known as Bluetooth, and IEEE 802.16, known as WiMAX. However, recently the Bluetooth Special Interest Group, or SIG, as it's known, has taken over maintenance of the 802.15 standard. There's a link there to their website. These standards represent different wireless data services, and they're constantly changing amendments to the original standards. If you want, you can find these standards at www.ieee.org. What about cellular? Well, quite separately, the wireless cellular industry has their own organizations to promote and standardize their systems. Early on, there were several cellular organizations that were aligned with the type of radio technology that was being used for different segments of the industry. As the technology matured and the industry was driven by a desire for wireless data over the cellular system, a more global approach to cellular evolved. The ITU oversaw the IMT 2000 initiative, a proposal to create the third generation, 3G, of cell phone technology to provide high-speed, at the time it was high-speed, wireless data over cell phones at the start of the new century. Since that time, the cellular industry has now gone through two evolutions, first 4G and now 5G. During that time, various radio transmission technologies, RTTs they're called, have fallen out of favor and others have gained favor for the transmission of high-speed wireless data. The ITU is now overseeing the IMT 2020 initiative, which is basically 5G and has various updates. Presently, the organization charged with overseeing the technical aspects of the cellular industry is known as the 3GPP, which stands for Third Generation Partnership Project. This is a collaboration of 7 major worldwide cellular wireless telecommunications standards organizations. They have written the system standards that will comply with the previously mentioned ITU's IMT 2020 requirements, also known as 5G. This is a standard driven by applications of the IoT, which includes ADAS and autonomous cars, and they will continue to write new standards that will extend and update this service. So, what about government organizations? Well, 2 of the most important government organizations in the United States involved with the research, standardization, and regulating of emerging automotive safety technologies that involve wireless technology are the National Highway Transportation Safety Administration, called NHTSA, and the United States Department of Transportation, U.S. DOT, Intelligent Transportation System. So their websites are given here. What are their roles in the automotive area? Well, the U.S. DOT opened in 1967, has a history of being involved with the improvements of all aspects of the U.S. transportation system, and also the term Intelligent Transportation System, or ITS, was adopted way back in 1994, almost 30 years ago. In 1997, ITS America petitioned the FCC to allocate 75 megahertz of spectrum in the 5.9 gigahertz band for what was called DSRC, or Dedicated Short Range Communications. And these frequencies could be used for high-speed data transmission for communications-based active safety applications for vehicles. And mind you, they have not been used too much so far. How about the FDA and the medical devices industry? The medical industry in America is under the U.S. Food and Drug Administration, or FDA. The FDA regulates the sales of medical device products, including diagnostic tests, in the United States and monitors the safety of all regulated medical products. In the U.S., the FDA regulates the sale of medical device products. Before a medical device can be legally sold in the U.S., the person or company that wants to sell the device must seek approval from the FDA. To gain approval, they must present evidence that the device is reasonably safe and effective for a particular use. At this point in time, we're probably a little bit sensitive to this because of COVID-19 vaccines. We've seen the process, and we know about emergency use from the FDA. At this point in time, we're almost to the point where they probably are going to actually give some of the vaccines permanent status. What about the FDA and the FCC? Well, the FCC and the FDA have been working together in this area for some time. There's a link about this. Wireless medical telemetry is generally used to monitor a patient's vital signs, for instance, pulse and respiration rate, using radio frequency RF communication. These devices have the advantage of allowing patient movement without restricting patients to a bedside monitor with a hardwired connection. And there's another link here that talks about this. So here's typical medical devices. There's a marketing graphic, shows an EDAN wireless monitor that provides for patient mobility while being monitored. A closer lookup, or a more closely seen picture here is this typical wireless medical device being an EDAN IT20. It's a Wi-Fi based telemetry transmitter with standard ECG monitoring functionality and optional pulse oximetry, which is your oxygen level. Communicating with a MFM CMS monitoring system in real time. That was shown in the prior slide. The IT20 enhances the overall monitoring scenario, especially for in-hospital mobile cardiac patients and rehabilitations. It can also be applied as a backup device for emergency cases in hospitals. And you can see it's got 60 and 99 on there, so probably the 60 is the pulse rate and 99 might be the oxygen level. Other typical wireless medical devices. So here's a picture of something worn on the wrist. Notice it's got a sensor which goes around a finger there. So this is a wireless continuous non-invasive blood pressure and vital signs for Philips IntelliVue patient monitors. And this is compatible with the Philips IntelliVue MP40-90 and MX400-800 monitors using the Philips EC10/EC5 IntelliBridge module. So as most of us are aware, new wearable devices have become quite popular in recent times, and you can see the monitor, what the monitor would see in the insert there. There's a great deal of product development, new and innovative wearable medical devices that transmit data wirelessly. So again, more about the FDA and the medical devices industry. So the Federal Communications Commission, or FCC, establishes a wireless medical telemetry service, which is called WMTS, by allocating specific frequency bands that are used exclusively for wireless medical telemetry. The WMTS set aside 14 megahertz of spectrum in 3 defined frequency bands: 608 to 614 megahertz, 1395 to 1400 megahertz, and 1427 to 1432 megahertz for primary or co-primary use by eligible wireless medical telemetry users. Additionally, many devices already use Wi-Fi bands to relay their data via the internet. So here's a graphic that shows some wireless e-healthcare examples. On the left-hand side, a body area domain, they call it. It looks like somebody's in their house, so we have body sensors. We look at environmental conditions, ambient sensors, body sensors, more body sensors. It looks like somebody's running on a treadmill there. Then we call that, again, body area domain. In the middle, we have communications and networking domain. So what happens is you notice that we have 3G, GPRS, GSM, and Wi-Fi. Some of those are ancient technologies at this point in time, and there are a bunch of servers connected to these things. It shows a monitor, a PC, and a smartphone. So then on the far right, we have the service domain, and again, you see a hospital up top, ambulance, a nurse, a doctor. Looks like somebody doing the Heimlich maneuver there, and there's what's called an RHM server, which I'm not really sure what that stands for. But this is a little bit older diagram, but it indicates again that e-healthcare can be in a clinical environment, like in a hospital, or in your own home. And again, there's a lot of networking involved and wireless technologies involved. So again, the future, I think I've shown this slide before. It's a prediction, a forecast chart from 2020 that indicates the number of IoT devices that are going to be connected to the internet. I think this one's data as of November 2020, so everything up through 2019 is real, an actual, and from 2020 to 2025, we have expected, I guess, what E stands for in this case. As mentioned elsewhere, this is the start of a new paradigm where M2M traffic starts to exceed human application traffic over the internet. What about other industries? There are many other industries that will use wireless IoT devices to implement cyber-physical systems and/or other type of control systems. Depending upon the industry, these devices will need to be certified. For instance, for the electrical industry, the NEMA, National Electrical Manufacturers Association, is a body that certifies electrical devices. Certification will need to occur on an industry-by-industry basis. So let's summarize what we've talked about. As we have seen, licensed wireless technologies are subject to standards, and RF emitting devices are also regulated. Various standards organizations exist all over the world. The ITU is an international standards organization, while the FCC is in charge of wireless standards for licensed operation in the U.S. As new wireless systems are conceived, they will need to meet the wireless standards in place at the time or generate new standards. Unlicensed wireless operation is also subject to various de facto standards that are in place to ensure interoperability between various manufacturers of wireless products. And that's the end of this presentation.